Thank you for joining the webinar. So this is Timeplus Live, a monthly webinar for us to share our product update, to work with our customers, community members, partner, and share our customer stories. And most importantly, to get the feedback from you guys, and feel free to ask any questions, and you are going to get the real-time answers. The agenda is quite simple today. That is, we will have a panel discussion regarding the Apache Iceberg integration, the Apache Iceberg 101, how it works with the data warehouse, data ecosystem, and how Timeplus can be part of it. And I will do a quick demo, and Ken will share more updates from Timeplus, and we can end our session with more Q&A. The iceberg is the key theme of this webinar, and I'm so glad to invite our special guest, Lisa, to join the event. And maybe, Lisa, you can go ahead, introduce yourself.
Hi, everybody. Thank you, Joe, for having me and the rest of the Timeplus team. So a little bit about me. I'm the product manager for a company called Datastrato, and we're the creators of Apache Gravitino, which is one of the first companies to release an Iceberg REST catalog service. So there's been a lot of talk about how Iceberg is used and open table formats. And so we do a really open data catalog that inherits from other data catalogs, which is really exciting. I also do a lot of work in the data ops field, as well as in different sectors of LFAI and data.
Yeah, that's awesome. You also join a lot of meetups, talks in Bay Area, and I think there's a lot of other conference anywhere. I think the Iceberg Summit is going to be happen soon. So for those who are not that familiar with the concept of the Apache Iceberg, why it's a big deal, right? I mean, can you share a little bit about why people are so passionate or crazy for this?
Yeah, I think that one of the reasons why people love open table formats is because it's really targeting this huge pain point, which is this management of storage and compute, right? And the more that you're able to decouple that, the more that you're able to have more control over your stack and sort of the cost of where you're actually paying for things. And it's all towards the same goal of vendor neutrality. And so there's a lot of buzz around this in terms of the community, particularly because I think Iceberg is one of the more user-friendly ones to come in on the market for this reason. And so when we think about the community-driven aspects of Iceberg, I think that it's natural that a lot of folks will want to come in and talk and meet about it. But for those who don't know what Apache Iceberg is, really it's this open table format that initially came out of Netflix, created by Ryan Blue and a bunch of amazing engineers. And what ended up happening was that it created these abstractions on top of data files known as like metadata files and these manifest lists that allow you to point to different parts of your storage while staying agnostic to the storage underneath it. So you can have, your S3 files under there, you can have whatever data files, pretty much only relational tables that we support currently in Iceberg. And then what you can do is use the catalog that's on top of that to point to where those files are and then manage it in really specific ways. And there's some really cool things like time travel that you can do with Iceberg. There's very specific ways that you can handle compaction and optimization. And so I think that's why people really enjoy it.
And what's the, say, top 3 reason people choose Iceberg? Is that about costs? Is it about vendor locking or no vendor locking or something like that?
I think it's really about storing your data where you need it to be stored. So there's this huge issue with data silos. Your data's in many different cloud systems. You're working on-prem. And a lot of the folks who previously used, say, something like Hive or Hadoop really are looking for another big data solution that can hit sort of that same vendor neutrality. And so that's really where it is, I think, is the ability to store what you want, where you want. And the more it gets adopted, the more powerful it becomes.
Oh, yeah. People who are new to Timeplus, you may know that we are implementing in Timeplus, right? And Iceberg, I guess, I briefly checked the history. That is, it's at the very beginning, they use a bunch of Java-specific technology such as Marshall and Marshall serialization. So it's not very friendly to non-Java ecosystem, right? Even today, I guess by default, people use like Apache Spark to get data in or query it. But it starts to be more open. I see you mentioned the catalog, the REST catalog. Do you think that's in the direction of have more like multi-engine using different programming language so everyone can fit into this new Iceberg ecosystem?
Yeah, you hit it right on the head. I think that when a lot of people were developing in AI, they were using a very Pythonic stack. And then all of a sudden we realized, oh, the data that we all need is stored in all of these Java applications that we need. And so how do you converge between the two? And there was also this huge issue of, a lot of conflicts and locks happening as you're trying to create changes to these files. And so the more that we move towards a server side and the more user-friendly that we make it by just offering something that's simple and easy to predict like Rust, the easier it is to configure all these different tools and engines, right? And so I think that a lot of the major big data engines that we see, like Spark, Trino, et cetera, they all support Rust inherently. And so you're able to really get a predictable input output in terms of, the type of requests that you're able to make. And so it's this big equalizer. And then you as an infrastructure team can handle all that logic in terms of how you want to handle different conflict resolutions, how you want to handle your permission management. And no longer is it really, a big roadblock when it comes to, we're trying to update this thing at the same time, but there's a conflict and now everything's just breaking in production.
Yeah. So maybe one more question before I ask some technical spicy one to Ken. But so Lisa, your company or your project, Apache Graphino, is also one of the open catalog implementation. And also there's I'm not saying this is elephant in the room, but there's also like Unity and Polaris. Why people are implementing or try to build a different catalog service, why it matters?
Yeah, I think again, because the Iceberg catalog inherently is very simple, like there's a spec for that catalog, for that REST service, but it's not like the catalog inherently has governance features. And when we think about data catalogs, we think about governance first and foremost. So generally speaking, you still have to, really implement your privilege systems and your RBAC and your data lifecycle management while leveraging, the Iceberg catalog because it's not innate in the Iceberg catalog. So you still have to write a service for it. A lot of the different, organizations out there that you listed are focused on kind of just supporting Iceberg right now, just because Iceberg is so big and it's, becoming this new standard. But there's also other open table formats that exist as well, right? There's Hudi, there's Pymon, there's Delta Lake. And oftentimes when we look at the larger picture, maybe 10, 20 years from now, we'll see Iceberg used alongside many other different things. And so Gravitino's approach is to really go, okay, Iceberg is one of the things that we support really well, but it's not the only thing that we support really well. And so if somebody wanted to, enforce the same policies against both their Hudi tables or their Postgres tables or their Kafka streams, can they do that all in the same layer, including Iceberg, not just thinking about only Iceberg, right? And it really depends on your use case, which catalog you might want to implement in that case.
Cool. Yeah, and maybe one question to Ken. I guess you will demonstrate some cool stuff today. But before that, we are so glad to be maybe the first open source C++ implementation for Iceberg read-write, even before our friend in DuckDB and the ClearHouse. Why so hard? Why there's no other open source C++ SDK or driver for Iceberg?
Yeah, thank you for asking this. So first of all, C++ language itself is not easy. It's not easy at all. So there's a lot of evolution. Even with the latest evolution, it's not easy to tackle with the C++. This is the first reason. I think this is exactly why people basically hesitate in building the C++ read and write for Iceberg. I think this is the last piece, maybe a missing piece in the industry. And lots of the company like Red Panda, ClickHouse, or even StarRocks, basically they are creating their own C++ version, but with different implementation. From my perspective, Timeplus C++ version of the Iceberg read and write is basically Apache 2 open sourced. I think it would be huge benefit for the industry for the reference. And also they can even copy and paste of the code to make it a reference implementation or standard implementation. Yeah. So, and the spec is just a spec. There's a lot of nitty-gritty details regarding the engineering, So for implementing the specs, there's a lot of details like Lisa mentioned.
Yeah, Lisa, thank you for the answers. And let's see whether there's any questions in the Q&A sessions. Seeing is believing, right? So I'm going to share a demo, but before that, just a quick wrap up. There's a lot of concept or components for the Apache Iceberg ecosystem, right? The catalog is to manage everything, but essentially you choose a storage tier such as S3, which is a high availability and also cheap. And you write to it, and you can have other different engine to read it. And in the meanwhile, there can be a system to keep improving the efficiency for the storage and make this faster to be queried. And this is even more fun way to show that is there's a lot of superhero. Everyone have different expertise, but as a team, you can come up with a nice data pipeline. I'm going to share a very quick demo regarding how we can leverage Timeplus to read the data from, for example, MSK, the Microsoft AWS managed Kafka, and process it and send that data to the Iceberg so that you can store them efficiently and cheap in S3, and also can use different tools such as Athena or Spark to query them. And you can see that is we have data set up. It's a random stream, and it will send the data to the MSK. And the MSK is a Kafka external stream. And we are going to using a materialized view to read from this MSK. You can see this. We apply some transformation. For example, for next event, we can get the number of events and get the min max. And we use this materialized view to send the data to this Iceberg transformation Iceberg table. Right. So what I need to do that is I just need to go to our SQL console and load up this more like notebook, and we can create a materials view so that the data can be keep generated and sent to the MSK. And you can also see this MSK integration is using the secure IAM role, so there's no hard-coded AWS potential in your DDL. So the data is already enabled, and back to the SQL console, for example, I start a Spark SQL so that you can using different engine to query it. Right, you can see there should be a different count over time. Right, so starting from 5,000 and a bit more, and if I run again, so I can refresh it and as well as to count it. Again, Spark is not known for efficient query, so using Timeplus actually will be faster. But you get the idea that is Timeplus people get the data from the MSK and process it, no matter in a simple way or in a sophisticated way, even using user-defined function, and we can continuously write it to the Iceberg. And other engines such as Spark can query it. And you can also leverage other tools to optimize the table so that it will be more efficient, avoid smaller files. And yeah, this is a very quick demo. And actually, I do have other setups, such as using the Gravitino coming from Lisa's project. And we are working on the Polaris and other systems. And even you can using DuckDB. But yeah, I guess I can share some demo later on.
Okay, so every single month, we will basically get things out every single month. So in the last month in February, we have a lot of cool stuff to already deliver to our customer. And this month we have several big stuff. Number one is basically we have elastic compute nodes support in Timeplus cluster. And also we have the auto-scaling materials view we will do demo in the next. And we also have the read and write Apache Iceberg engine, table engine. So most important, the C++ version of the engine is already open sourced. And we have the Postgres integration S3 tier storage. And we have some cool, nice feature in Timeplus console to monitoring the cluster as well. So next month, we will have even more cool stuff like new JSON type support, which handle the basically MongoDB documents pretty seamlessly. And also we have more updates for the mutable stream, and also one of the hot ask from our customer is basically Datastrato queue support. So yeah, so for the first of all, the auto-scaling materialized view. So in this release is a very big thing. So the problem we are trying to resolve is basically our customer has a lot of materialized view. They have tens of thousands, sometimes 100,000 materialized view to run. And the workload can have peak time and have low volume time. And what they like to do is basically when the workload is high, could you please auto scale the computation according to the workload? And if the workload is small, dropped a lot, so we can auto scale in according to the workload, which largely reduce the TCO. And so to create a materialized view, auto scaling materialized view, basically it's very simple. Number one, we basically like to create a S3 disk, which is for checkpointing. And also we create a materialized view, which use the S3 checkpointing, and that's all. People basically everything is automatically happening underneath. So from architecture point of view, Timeplus cluster has two tiers. There will be the number one is persistent tier. We have the Timeplus controller, and we also have the Timeplus data nodes. And on the other hand, we have the computation nodes, which is basically running the auto-scaling materials view. For example, if we have tens of thousands of materials view, we can schedule the materials view to run on the computation nodes. Materials view can be very stateful and can be stateless. Stateless materials view is just like ETL, very simple. And the checkpoint size will be small. But for the stateful materials view, like aggregation, like join, the internal materials view query state could be big. And we will dump all of the materials view state into the centralized cloud storage. We are using S3 as a checkpointing. So this is exactly the key point. When we reschedule the materials view from the computation node, we do not need to move the checkpoint around. We basically can pick up from the S3 checkpointing and start from there without data duplication and also data loss. So the next thing I'd like to do the very quick demo regarding the auto-scaling materials view. And the setup is basically we have a Kafka topic, which is in JSON format. And we have data generation tool basically sending the generating data to the Kafka source topic. And we will have a bunch of create more materials view into the cluster. And the materials view will schedule to the computation nodes. And as the workload increase and more materials view has been created, the computation node will be auto scaling according to the workload, and then writing the data to the downstream ClickHouse. We have the setup. Initially, we have a cluster on the left-hand side, and we have 6 nodes already, and 2 data nodes, and also 1 computer node on the metadata nodes. And on the right-hand side, we have the console. We like to create the materials view, sending the data to ClickHouse, reading the data from Kafka topic and sending the ClickHouse to ClickHouse. And we create the materials view, like 20 materials view. And from the left-hand side, we can see we have 6 nodes online, and one of the computation nodes, CPU utilization is not that high. It's like 25% CPU utilization. As we create more materials view, because we do not generating data yet, and we start generating the data. We like to emulate lots of data volume. And each of the materials view is basically doing the computation because it needs to parse the JSON and do the JSON extraction and sending the data to ClickHouse. And from the left-hand side, we can see the CPU utilization is basically pretty high right now. It's like 2 CPU already consumed. And also from the auto-scaling group, AWS auto-scaling group is already kicked in. It's auto-scaling the computation nodes to handle the workload. And the computation node may take some time to join the cluster. So right now we have another computation node join the cluster, which is node 7. And from the CPU utilization as well, so we have spread the workload to node 7, which is 200% CPU utilization. Because the computation node is pretty small, it's like you have 2 CPU. And we have more computation nodes join the cluster, we were spreading the node to different computation nodes. Because we have very large volume of data, and we need more computation nodes to handle the load. And even from the current CPU utilization, we can see it's all maxed out. And right now we have 15. The auto scaling group basically has 15 computation nodes. The CPU utilization is still high. It's just like max out the CPU utilization like 2 CPU. More computation nodes join the cluster, and even more computation nodes join the cluster. And the CPU utilization is still like 200%. It means that the workload is actually still too high to handle all the material view computation. Right. And it will be more computational join the cluster. Right now we have 13 computation nodes join the cluster, and the workload is still like for the new join the cluster is basically a little bit lower, but for the existing computation node, the workload is still high. Right now we reached the maximum of the auto scaling group size, which is 20, and the CPU utilization dropped a little bit. See. On the left hand side, civilization is job is like 100% of civilization and also ClickHouse has a lot of data, around 200 million of rows in ClickHouse. Right now, the CPU utilization of the whole cluster computation node drop a lot, like from the 200% to like 70%, 75% of the computation nodes. So this is basically conclude the auto scale out scenario when there's a lot of workload and we need to provision the computation node to do the computation for the materialized view. And next, I like to do the demo basically when the workload is basically reduced a lot. The EPS is like 10 EPS per second. And we will emulate the workload job, and we will see the scale in will kick in. The AWS EC2 auto scaling group will kick in, and we will monitor the termination of the EC2 box. And the CPU utilization drops a lot because the workload is basically very little right now. It's like 10 EPS per second. And since that, when we terminating the EC2, the cluster will remove the EC2, the computation nodes. It's just like an ephemeral nodes, and we will remove that from the cluster. Yeah, more EC2 box has been terminated, and our cluster monitor will basically reflect this kind of scenario in a maybe I think it's 30 seconds. And this from the node status, we can see lots of computation node has been offline because they have been decommissioned. Okay, yeah, that's pretty much about the elastic materials view or auto scaling materials view, auto scale according to the workload. And the next Postgres external table, we have new addition. Basically, people can do query the Postgres and do the join against with Postgres without any data moving. This is very, very handy. And also Postgres dictionary, which is super helpful for the join enrichment. The difference is basically people basically can do the one shared copy. So you have, for example, you have lots of materials view or a lot of query need to join the same table, and the dictionary basically provide a proxy to the Postgres table, and also with some of the cache mechanism locally, and that will be reduce the workload to the production system. And also we have the one single copy of the cache, so which is very powerful when do the data enrichment case. So S3 tier storage, right now user can create the tier storage for the stream. For example, you have a lot of historic data, and they can tier the data according to the timestamp, tiered store according to timestamp or other expression. And in this case, for example, we have 7 days tier 2 code. Basically, we can create a storage policy and the tier to the S3 disk according to the storage policy, and also the disk is basically pointing to a S3 buckets. Internally, we have some of the mechanisms evaluating the data when they ingested in data to the Timeplus and move the data around to S3 storage according to the TRA storage policy.
Thank you, Ken. Yeah, there's a lot of cool stuff in this short 20 minutes. So as I mentioned, that's we're not just open source our Iceberg integration or read write, but also those we have this elastic way to run thousands of or even more materialized view for different streaming workload, and the data can be put into the S3 or other storage for unlimited storage and retention. And I think we have a question from some questions from the audience. Maybe we can take one. So the question is, I guess this is for Ken for regarding the elastic materialized view or computer node. So how does action merge all the data so that we don't end up with too many files or parts? Is the computer node able to do those compaction?
So yeah, the materials view right now we are demoing is not related to Iceberg. And also if the storage if we ingest the storage data to Timeplus, yes, Timeplus in the background, Timeplus stream basically has auto compaction and the merge and sorting process just like Iceberg does. So if user using Timeplus as a storage, absolutely, we will do the compaction automatically. Yes.
Cool. Yeah. Sorry, there's more question coming, but maybe we can only take one more, and the rest we can use our community Slack to have more discussion. So yeah, people really care about those tier storage and high availability. So
right.
In the case of the data is put into the S3, for example, cold storage, if the server is faulty for some reason, can we set up a new node to read the data from S3?
Yeah, so I think our user is asking the Proton server, right? Proton is open source and it's a single instance setup. For Timeplus Enterprise, yes. So we can using the S3 as a snapshot of the backup of our data. But Proton right now, we do not have that capability regarding the recovery for that feature. We do not enable this kind of recovery in Proton OSS yet.
Okay, cool. Yeah, again, thank you everyone to join the session, and really appreciate the great insight coming from Lisa. And yeah, Iceberg is, I guess we are in the beginning of something very big, right? So people saying this might be a new Hadoop, but again, the Hadoop ecosystem is great. So Iceberg is even bigger, and the people, we are happy to be part of it. And we are already open source our code. We are working with other community to how to share that. And today we make our Timeplus Enterprise 2.8 available. Feel free to check our website, our documentation to try it, give some feedback, join our Slack, and also follow up with Lisa regarding the open catalog, Cupertino, and other projects. And our next webinar will be sometime soon next month. So feel free to join as well. Okay, thank you very much, everyone, and enjoy the rest of the day. Thank you. Bye.
Thanks.
Goodbye.
Bye.
Thank you.
Thank you. Bye.